Today is kind of a review a little bit. Page 265. We are doing 1 through 18 again. Or 16 actually, that's right.
16. Woohoo!
It's a lot of synthetic division. You guys remember synthetic division?
I'm not a paper mule.
So quick.
Take the number down.
You do what now?
I'm gonna start charging
Take
for
the
this.
number down and then you multiply it by the remainder.
Okay. Number 1 says use the remainder theorem to find the remainder when that polynomial is divided by each binomial. So we're just dividing and finding the remainder basically. I don't think they really said the directions quite like they meant to. Basically, okay, I'll explain it later. What did we start by doing on the synthetic division?
You draw your little square in the top left.
Okay, a little square, what else?
And then you draw the numbers, and then you draw a line, and then you do
Okay,
the problem.
the coefficients go across 3, 7, negative 2, and 6. And what goes in the box?
Would it be 1?
1. Okay,
Oh, okay.
here's the thing. Yeah, remember it was opposite of x minus 1, so you put positive 1. Whatever we get for the remainder down here, you guys remember the remainder ends up right here,
Yeah.
is the same thing as what we would get if we plugged 1 in normally into the problem. Like plug 1 into the x. Whatever would come out for that is the same thing that would come out for the remainder. That's the remainder theorem. Anyway, we're just dividing and finding the remainder. So remember how we do this? Add down, multiply up by 1, add down, multiply up by 1, add down, multiply up by 1, add down. So the answer on this one is just going to be that 14. So what you should find if you plug in 1 normally into x on that is that it comes out as 14 also.
So is that all 1? Like, is that what we're trying to do? Is just
Yeah,
like,
that's it.
like that?
Yep.
Oh, okay.
Alright, number 3, same thing. 3, 7, negative 2, 6. What goes in the box?
Negative 2.
Negative 2. Opposite. Add down. Multiply up. 3 times negative 2. Add down. Multiply up. Add down. Try not to go too fast. I get these wrong a lot because I try to go as fast as I can. Add down. 14.
Hey, the same answer.
Yep. Number 5. Use the factor theorem to determine, it sounds fancy when they call it a factor theorem, but how do we know if x minus 2 is going to be a factor of that big old thing over there?
You use synthetic division.
And how do we know? How can we tell?
If the remainder is 0.
Right. Factors should multiply into it evenly, right? Or divide evenly, better to say. So if the remainder is 0, we're going to put yes. If the remainder is anything other than 0, we're going to put no. So coefficients are 1, negative 10, 17, 52. This one's kind of a big one. 52 and negative 60. Let's make sure I copy that down right. Because that would be a shame. 1, negative 10, 17. Okay. And what goes in the box?
2. Oh, this one's going to be a doozy. Pulling up my calculator.
Okay, add down. Well, it might come out as 0. I mean, about a 50-50 chance this will come out as 0. Since it's the first one, I would guess it will come out as 0. 1 times 2 is 2. Negative 10 plus 2 is negative 8. Negative 8 times 2 plus is 1 times 2. No, I was wrong. It's not going to work. Plus is 54. Times 2 is 108. Remainder is not 0. Whoops.
apply to it.
Oh,
So
I'd
that's
say
no.
yes.
Wait, is that negative really, or?
It's positive. It was supposed to be positive.
Why did we put no?
Huh?
Just cause it didn't equal zero?
Okay, that means it's not a factor. That doesn't multiply by something else to give the original thing. It doesn't divide evenly. Like 4 is a factor of 20, and if you divide 20 divided by 4, you're not going to have a remainder. Okay. Number 7. I should have just cheated and you guys can't use this trick. There we go.
Wow.
Beautiful.
Really?
I'm not sure that helps me much, but
I don't think.
negative 2. 7. Okay. Add down, multiply up. Add down, multiply up. Add down, multiply up. Add down, multiply up.
If you look at that, it's a 0.
0. What are the odds? Yes, that was a factor.
So if it's 0, it's yes?
Yes. 0 is yes. Any other number besides 0 is no.
Correct. It's like, it's asking, how do we know 4 is a factor of 20? If you do 20 divided by 4, you get 5 with a remainder of nothing, right? If you get a remainder of 0, yes, it is a factor. That's what they're asking. All right, number 9. This one actually is new. I probably should write this one down. X cubed, P of x equals x cubed. 5x squared minus 2x plus 6. This is kind of a challenging problem here. Okay. A rational root theorem. Do you guys remember what the word rational means?
No.
A rational number is anything that can be written as a fraction, so it could be like 2/3 or negative 5/9, or 7, or, you know, because all normal numbers can be written as fractions too, negative 9/5. Basically, irrationals are like square root of 7, pi, weird stuff. So if this has normal answers, the rational root theorem says that the answer is going to be factors of the last term over factors of the first one. So I should say the coefficient. So factors of 6 over factors of 1. I know this sounds confusing. Once you see it a little bit, it'll make more sense. What are factors of 6? What can go with
3,
6?
2.
1, 2, 3, and 6. Those can all go with 6. Technically, they could all, I'm not going to write this every time, they could all be positive or negative, right? Because you could have like negative 1 times negative 6. So they could all be positive or negative. What are the factors of 1? 1. And this could be positive or negative also. So the possible answers for this, if it has rational answers, are going to be this over this, this over this, this over this, and this over this. What's 1 over 1, and 2 over 1, and 3 over 1? No.
It's just that number.
It's just itself. So the possible answers are basically, on this one, it's 1 over 1 is 1, 2 over 1 is 2, 3 over 1 is 3, 6. So the possible answers are basically plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And they're not making us figure it out on this one, so we can stop right here and just say those are the possible answers.
I don't like that.
I probably should have defined the word root. You guys remember what a zero function was? Like if you set the function equal to 0, it's what x value makes it equal to 0. Did that? I don't know, it's like Thursday or something. Today they're calling it the roots, which are the same thing. So the roots, the 0, it's kind of the solution if you set it equal to, if you're trying to make it equal to 0. These are kind of all the same thing. So these are possible roots, possible answers that make it equal to 0. Oh yeah. The degree of the polynomial, the highest power, which is 3 on this one, tells you how many answers you should get. Now sometimes you get imaginary answers, so that's not always helpful, but you should, even imaginary answers, you should only get 3 answers. So it might be 3 of these should work. Okay, we're going to have to use that later. Okay. Number 11. This one's short and sweet. P of x, x cubed plus 8.
You look really excited.
No, it's not something funny. Okay, you guys remember what we did? Factors of the last term over factors of the first coefficient, the number in front. So factors of 8, are all these 1s in front? No, okay, 12 has a 4. Darn it. Alright, I'll help with 4. Okay, with 12. So what are the factors of 8?
1, 2, 4, and 8.
And what are the factors of 1? 1. So same thing as last time. It's 1 over 1, 2 over 1, 4 over 1, 8 over 1. It's 1, 2, 4, and 8. So plus or minus 1, plus or minus 2, 4, plus or minus 8. Actually, this one would be pretty easy to solve since it's so short. You guys know what cubed plus 8 equals 0? 182, -2. That's one of the answers. There's still 2 more answers. We're not going to solve it though. We'll probably better look at 12 because there's a number on the front. It might confuse us. I wish they would have done that on number 11. 4. Okay, I'm not going to write 12 down. So it's factors of the last number over factors of the first number. So the last number is 7. First number is 4. What are the factors of 7? 1 and 7. What are the factors of 4?
2, 1, 2, 4.
1, 2, 4. The order doesn't really matter. I'm just putting it in order. Okay, so it could be 1 over 1 or 7 over 1, which means 1 and 7. What else could it be? 1 over 2 and 7 over 2. Or 1 over 4 and 7 over 4. We're going plus minus, God forbid.
That's weird.
They're fractions.
Can't say I'm a fan.
That wasn't that hard, was it?
It's weird.
The hard part is actually solving it, which we're
About to start doing it.
getting close to. I was going to save it for tomorrow, actually.
Oh,
17 is well, it's kind of like solving. Okay. 13. So here's the thing on 13. F of 3 means what? How do you find F of 3?
You plug 3 in for X.
Right, you just plug it 3 in and you see what you get. What we're using on 13 though is instead of doing it normally, we're going to use synthetic division / now it's called synthetic substitution. Although they still call it synthetically dividing. Basically, we're going to do synthetic division, but we're going to put 3 in the box, and where the remainder normally goes is going to be the actual answer.
Wait, would you put 3 or negative 3?
Just 3.
Okay.
So we're not actually dividing, we're plugging it in, so it's a little bit different. So the coefficients are 4, -10, -26. And 60. And in the box goes 3. Okay, so you could kind of do it the old way, and I don't think this really makes it any easier. Maybe slightly, I don't know, but it's the same thing as plugging in the old way. Anyway, so I'm going to add down, multiply up, add down, multiply up, add down.
Where did we get the -3 again? I'm sorry, I zoned out.
It's a positive 3.
Oh, sorry, where did we get it?
It's asking for F of 3. What happened?
Lambda 0.
Okay, that means if we plugged 3 into the original equation and worked it out, you could check it if you wanted to, you should get 0 as your answer. So 3 is a root of the equation, which means x minus 3 is a factor of the equation. All of it kind of is true at once.
So is that how we write the answer?
Yep, that's it. You guys could plug 3 in there and see if it comes out like it says. 4, -5, -2, and 9. And we're plugging in R 1/2. Uh-oh, challenge. Challenge accepted.
Speak for yourself. Just kidding.
Add down 4. What's half of 4?
2.
2. -5 plus 2. This is where we go off the rails. -3 times -1/2.
Negative 1.5.
Yeah, you might want to think of it like a mixed number. It's -1.5 minus 2 is -3.5. Or -7/2. Times 1/2 is -7/4. And 9 times 4 is 36, so that's how you would do it without a calculator. 36 minus 7 is 29/4.
Doesn't equal.
Oh, I did it wrong.
You have to say someone was a little fishy about that. Didn't know what.
Somewhere in this region. -7/2 times 1/2, -7/4 times 4 is 36. Same thing. Okay, try again. Did I look the wrong spot? 4, -5, -2, 9. Oh, I see. They're missing a term.
Did we add a term?
Well, kind of. What normally comes after x to the 4th?
X to the third.
X to the 3rd. You see how they have no x to the 3rd term?
Does that mean we have to put 0 for it?
So yeah, you're supposed to put a fill in a blank.
So it just skipped it?
So the
So,
that's
well, it just doesn't have one. So where the x cubed term should go, we need to put a 0.
that's rude.
So watch out for that. Let's look right now and see if there's any more like that. No, yeah, 16 is like that. 16 is missing the x squared term. -5, -2.
can't believe they do
All right.
something like that.
Here we go again. Add down, multiply up, add down, multiply up. This is going much easier. Add down, multiply up.
Oh, this is a lot.
Add down, multiply up, add down.
Wow, that was like 99% easier.
Yeah.
It's crazy, dog.
Alright, why don't you guys try 1 through 16?